Hi everyone, we will be doing the second chapter for this course, and obviously the first chapter there was not much of maths or whatever. However, here there will be a little bit of maths. There will be maths. There will be maths involved. There will be not complex maths, but pretty simple maths involved. And here we're going to do one master question, like one whole question that explains literally everything in terms of the core concepts and whatever. And I think that's much easier. Wait. It's pretty easy. Like, probably have done this in high school physics, but if not, completely fine. If you were not doing an education, that's completely fine. I'm going to teach you everything here. Don't worry about it. So let's begin with chapter 2. So for anyone wondering, this book, like the book that we're using, so this is chapter 2, motion along a straight line. And obviously, if the book that you're using, the book that I'm going to use is the University of Physics with Modern Physics 15th edition. So from there, we're going to do the questions. From there, we're going to do all the questions, all the explanation and whatever. Don't worry about, we're going to explain everything. All right. Now, let's begin. So we have x of t. So the question was, a particle moves along the x-axis. So we have x of t is equal to 4t square minus 2t cube. This is the position of the particle in meters. This is the position of the particle, right? And the range of for time steps is 0 less than or equal to t less than or equal to 4. We have 0 less than or equal to t less than or equal to 4. And obviously, if you want to, they gave the displacement, they gave the range in time taken to calculate the displacement. So this is everything from chapter 2. All right. To calculate the displacement, we're going to say del x being x of t2 minus x of t1. So now, let's say, for example, I said t1 was 1 seconds and t2 is 3 seconds, right? So if I say t1 is 1 second and t2 is 3 seconds, then I'm going to say x of 1, x of t2 minus x of t1, and t2 being x of 3 minus x of 1. Now, obviously, what is my general x of t equation? So my general x of t equation, then I'm going to have 4t square minus t cube. And for x of 3, then we're going to have 4 3 square minus 2 3 cube. So that's going to be 36 minus 16, which is 20. And for t is equal to 1, then I'm going to have 4 t square minus 2 t cube. I'm going to have 4 1 minus 2 1, which is 2. So my x of 3 is 20 and x of 1 is 2. I'm going to have 18. So it's going to be 18 meters, right? Did I 4t squared, 2t cube? T cube is what? 8. 3 square is 9. Yeah, we're doing correct. And so it'll be 18 meters, right? That's how you calculate displacement. Displacement means the difference in distance between the latter time step, and the previous time step. Average velocity, or usually you call it velocity. So first of all, to calculate the velocity, you typically differentiate it. Obviously, you're going to differentiate it. So we have 4t square minus 2t cube. Now, first of all, v of t is dx by dt. And if I look at x of t, my general x of t's equation is 4t square minus 2t cube. Obviously, you can differentiate that. And if you don't know differentiation, I have a specific playlist, Calculus 1. I have a Calculus 1 playlist, 1, 2, and 3, where I will be explaining everything from Calculus 1, everything from Calculus 2, and everything from Calculus 3. I'm going to explain all those lectures. Make sure that you're enrolled in that, because all those differentiations, all those integration that you're going to encounter, all those will be present here. All right. So this we can do dx by dt, which is simply v of t is equal to 8t minus 6t square, right? So 8t minus 60, sure, you can use the t equals 3, t equals 1, then 8, 3 minus 6, 9, then 24 minus 54, that is minus 30 meter per second. So there's a change in velocity, right? And then you can do 8 minus 6, it is 2. So minus 30 meter per second minus 2. So that is minus 32 meter per second. That's the change in velocity, right? So you got the instantaneous velocity, and now you also got the change in velocity. You also got the change in velocity. You also got the instantaneous velocity. I'm going to decrease the webcam. Oh, my bad. There. So you have the change in velocity and you have the instantaneous velocity. Cool. Now, acceleration. Step 4, acceleration. Now, if dx of t, so dx of t by dt is v of t, then dv of t by dt would be a of t, acceleration. And if I look back, I got 8t minus 6t square. My dx by dt was 8t minus 6t square. So my dv by dt would be 8 minus 12t. And to calculate the acceleration, actually 8 minus 16. And obviously, if you want to say dv by dt is 0, so let's say dv by dt is 0, then minus 8 will be minus 12t, t will be 8 by 12, or t will be 4623, right? 8, 12, 4, 6, 2, 3, yeah. And this is how you calculate the acceleration. So you know your time step, right? And you can also get your acceleration. If you want to get your acceleration, if let's say you say t is equal to 1, then 8 minus 12, it is minus 4 meter per second square. Cool. But you know your time step. Let's say dv by dt is 0. Let's say dv by dt, your acceleration is 0. And then 8 minus 12t, the time it takes to reach the acceleration for 0 will be 2 by 3, because minus 8 being minus 12t, and then t will be 8 by 12, which is 4 by 6, which is 2 by 3, right? Direction change. Now, to calculate the direction change, we're going to use the velocity equation. Now, when we did dx by dt, we had 8t minus 6t square. 8t minus 6t square. And if you try to, sure, you can, you can do 2t 4 minus 3t. You can do that. And considering the fact that velocity is 0, then if I say 2t 4 minus 3t is equal to 0, and 2t would be 0, t will be 0, and 4 minus 3t equal to 0, 4 is equal to 3t, t is equal to 4 by 3. And now I'm going to say that if my time taken, I'm not even going to consider that, right? I'm going to consider the 4 by 3. And if my time is less than, so if my time is less than 4 by 3, what happens is that my velocity will be greater than 0. Because if my time is less than 4 by 3, then as your time value decreases and you're already subtracting 4 minus the decreased value, it's like saying you're decreasing the value, and then you add that decreased value. So it will be the value of that, like value of, so the value, if you, so I'm just going to write the equation again. So 2t, 4 minus 3t, you try to decrease this value here, 4 minus 3t will actually increase, right? 3 minus 3t is small enough. And then on top of that, you're also decreasing the value. As you're decreasing the value, this overall 4 minus 3t increases. And that increased value multiplied by 2t dx by dt, this will go up. So as t is less than 4 by 3, v is greater than 0. And the vice versa, if t is greater than 4 by 3, then eventually you're going to encounter the velocity to be negative value, where you're going to have v being less than 0. So your direction of the velocity direction or the sign direction will change at t is equal to 4 by 3, right? So this will be my set time steps. If I were to draw a graph, I'm going to see 0 at 4 by 3. It's like whatever the graph is, obviously, whatever the graph is, if I have 2t, 4 minus 3t, I'm going to plot this graph on and on and on and on and on. And at t equals 0, I mean, t equals 4 by 3, t equals 4 by 3, I'm going to see that this 2t, 4 minus 3t ends up 0. So I'm going to see a 0 here at 4 by 3, right? So, I mean, sorry, x equals 0, y equals 4, but you get the idea. X equals 4 by 3, y will be 0. So my maximum position at t is equal to 4 by 3, then I'm going to have x of 4 by 3 is equal to, what was the equation? 4t square minus 2t cube. So 4 by 3 square minus 2, 4 by 3 cube. So 4, 16 by 9 minus 2, 4, 16, 64 by 27. So 16, 4, 64 by 9 minus 128 by 27. I can multiply this by 3. So 64, 128 plus 64, 12, 192. I'm going to do 192 by 27 minus 128 by 27. So 286, 4, my bad. 4, 918, 826, 64 by 27. Now, obviously, you can divide this by, let's see, 64, 27. So 64, 27 to 54, whatever. 64 by 27. This will be your maximum position, right? This will be your maximum position. And then you can plot the graph in respect to x of t and v of t. You can also plot the graph in respect to x of t and a of t. But graph is not what we're focusing on. We're focusing on the, how to calculate, how to solve this equation, right? And yeah, there will also be times where you have to use, if a is equal to constant, then you have to use the v is equal to v naught plus at, and x is equal to x naught plus v naught t plus half at square. And obviously these are special cases where you call them as Euler equations. We are going to do them. These are correlating to Euler equations. These are a little bit further, not now yet, but in general, in general, what we have solved is we have seen the position equation. We see the position equation. We're given the time range, 0 less than or equal to t less than or equal to 4. And then to calculate the displacement between the two time steps, we presume that t2 is some value 3, t1 is some value 1. And so we're going to say t2, going to do it right, do it here. So we're going to have t2 minus x of t2 minus x of t1, and x of, let's say t2 is 3 seconds, t1 is 1 second, and then I'm going to write x of 3 minus x of 1. Obviously, I'm going to replace the 3 here, and I'm going to replace the 1 here, whatever the value you get, and I got 20 minus 2, which is 18. Moving on, you calculate the average velocity. If you want to calculate the average velocity, v is equal to dx by dt. That's how you calculate velocity in general. And so 4t square minus 2t cube, then dx by dt would be v of t, and you're going to have 8t minus 6t square. And obviously 8t minus 6t square, we're going to again consider, if you want to find the change in velocity, then you're going to do 8 of 3 minus 8 3 minus 6 9, which is minus 30 meter per second, and 8 1 minus 6 1, which is 2 meter per second, and then eventually you're going to have minus 32 meter per second, because minus 30 minus 2. And then acceleration, where dx of t by dt is v of t. You can also do the second order differentiation, where dx square, d square x by dt square, which we are going to do in ODEs, but you can also do second order differential equations, where d square x by dt square is a of t. But keep it simple, dx by dt is v of t, dv by dt is a of t. The core concepts, dx of t by dt is v of t, dv of t by dt is a of t. And so I know that dx by dt is 8t minus 6t square. dv by dt would be 8, actually it's dv. dv by dt is 12t. So at time 2 by 3 or 0.666 seconds, the acceleration will be 0. Then your direction change. So you can also do direction change for velocity. You can also do direction change for acceleration. If I do dv by dt is equal to 8 minus 12t. So I can say that if t is less than 12 by 3, if t is less than 12 by 3, then my direction, so if t is less than, t is, let's do t greater than 12 by 2 by 3, then my acceleration will be less than 0. If I have t less than 2 by 3, my acceleration will be greater than 0. That's the direction change for acceleration. This is the direction change for velocity, where I got t as 4 by 3. If t is less than 4 by 3, then v is greater than 0. And if t is less than 4 by 3, then if t is greater than 4 by 3, then if the time or t is less than 4 by 3, my velocity will be less than 0. If my t is greater than 4 by 3, then my velocity is less than 0. One thing to configure is that t is equal to 4 by 3. This is when there is no velocity. Velocity is 0 here. So to calculate the maximum position, obviously you know that t is equal to 4 by 3. Then you're going to do that, all that stuff. So 64 by 27. This is the maximum it can go. 64 by 27 meters. Now, if you want to calculate the maximum velocity, you're going to take in hand that t is equal to 2 by 3, and it was 8t minus, what was the velocity? 8t minus 6t square. So 8, 2 by 3 minus 6, 2 by 3 squared. So 8, 2 by 3 minus 6, 2 by 3 squared. So obviously you're going to have 16 by 3 minus, so 4, 9, 4, 9, 24 by 9. So 16, so 48 by 9 minus 24 by 9, you're going to have 24 by 9. This is your maximum velocity, right? So maximum velocity, and you have your maximum position. Obviously, you can use the Euler equation, but we're not going to explain Euler equation yet. We need some time. Let's just finish the first steps, then, right? So this marks the end of. Actually, shall we do another one? Let's do another one. Yeah, let's do another one. Why not? Why not? Let's do another one. I mean, right? Why not? Yeah, let's do another one. So we have x of t is equal to 20 plus 15t minus 5t cube meters. So this is my position. I'm not going to explain much because we have done that previously. You can take your time, you can pause this video and then explain. But if you want me to solve it, we can. So step one, obviously you're going to do the displacement. 1 minute. Del x would be x of t2 minus x of t1. So if t2 is 3, t1 is 0, obviously you're going to replace the t2 values, then you're going to replace the t1 values, so you eventually end up 0. And then you calculate the total distance. So total distance, you're going to get the velocity first. So v of t would be dx by dt. And then obviously if I have 20 plus 15t minus 5t cube, then you're going to have 15 minus 10t square, and then you're going to do t is equal to 0, t is equal to 3, you swap them, whatever, all that stuff. You can also do that 15 minus 10t square is equal to 0, 15 is equal to 10t square, t square is equal to 15 by 10, t is equal to root of 15 by 10. You can do that. And then you get the position at the top, you get the distance, you get the up distance, you get the down distance, and then you get the total distance. Then you know how to calculate the average velocity. Average velocity would be dx by dt, that's the velocity. And then you can get the change in velocity at t equals 3, t equals 0, whatever. And then you know how to calculate the instantaneous velocity. To calculate the instantaneous velocity, you just differentiate the um, the position that is given to you, which is 20 minus 20 plus 15t minus 5t cube. You differentiate this 20 plus 15t minus 5t cube, differentiate that, you get your instantaneous velocity. And then you differentiate, so you get actually 15 minus 10t square. And then you're going to differentiate this again, and then you're going to get 2, so you have minus 20t. So that is your acceleration, right? And then you get your max height when it hits the ground. So long story short is that you get your displacement first, to get your change in displacement. It's literally the same thing. You get a change in displacement, so you get a displacement. So t2, whatever the t2 value is, whatever the t1 value is, you subtract them, you get the displacement. Number one. And then number two, you get your average velocity. Average velocity, the only way you can get your average velocity is your change in position by change in time. Now obviously change in position, you did the x of t2 minus x of t1, that's a change in displacement, and del t will be the change in time. And so whatever the change in displacement you got, whatever the change in time you got, divided, you get an average velocity. Instantaneous velocity is when you differentiate this position, not this position, sorry, this position, you differentiate that, that will be your instantaneous velocity. You get your instantaneous velocity, and then 15 minus 10t square. So 10t, sorry, 15 is equal to 10t square. Consider that it is 0 because it's an instantaneous velocity, so consider that as being 0. So t square, t would be root of 15 by 10. And then to calculate acceleration, you can either do d square x by dt square, or you can do dv by dt. And then a of t, you get the acceleration, and then you know when does it stop. You get your t values, you get your maximum position, maximum acceleration, change in direction. So the only way you can get the change in direction in terms of velocity is when you do the acceleration and then you get a t value. You can get your maximum position is when you do the differentiation for position, you get your velocity equation and you get the t value for velocity. You place that t value for velocity into the into the position direction, the position equation. So let's say, for example, 15 minus 10 t square, then my t will be root of 15 by 10. I'm going to plot this root of 15 by 10. This is where I got. So 15 minus 10 t square was the differentiation for position, which is velocity. Now t is root of 15 by 10. This is my time for velocity. And I'm going to place this in my maximum position and then find the maximum position. I'm going to do the same thing for acceleration. So I'm going to differentiate velocity, get the acceleration, and then whatever the time value I get, I'm going to plot that for maximum velocity. And then this will determine if this is less, then your velocity will be more depending on the equation. Cool. So that marks the end of chapter 2. It was pretty easy. You're free to ask any questions. I'm willing to explain all those all over again if you want me to do that. I will be doing that if you want me to do that. But this marks the entirety of chapter